Hello, everybody, and welcome to our very first virtual event of DevSecOn Netherlands. We are a chapter of the global DevSecOn community, an inclusive community that educates and enables developers in application security. Coming up, we'll be joined by Peter Bennink, Senior Security Engineer at Backbase, and my friend. And he's going to talk about implementing security in a Kubernetes-based SDLC. But before we start with the topic of the day, and I pass the mic to Peter, I wanted to quickly introduce myself. So I'm Davide Cioccia. I'm the founder of decoders.com. And as a chapter leader of DevSecOn Netherlands, I'm looking forward to growing the community and organizing amazing meetups. So feel free to send me a message if you have a cool topic or you want to share something with the community. Get in touch with us on Twitter. You can search for DevSecOn or using our Discord server. Actually, Discord is the best place to interact with our speakers and our fellow community. So we will be able to answer your questions and get in touch with other DevSecOn members. So if you didn't sign up yet, please go on the website, devsecon.com, and join Discord and join our DevSecOn Netherlands channel. And we'll be able to facilitate your questions, forward it to Peter later. Once the session is over, you'll be able to rewatch it on our website, share with friends, colleagues, social network, everyone, basically. DevSecOn is brought to you by Snyk, and our aim is to create a vendor-neutral space to share knowledge and best practices related to DevSecOps and security. Okay, so that's enough from me, and I'm going to bring Peter on stage. There we go. Welcome, Peter.
Hey.
How are you doing?
I'm good. How are you?
All good. Good to see you again.
Yeah.
Thanks for joining us, and thanks for bringing this amazing topic today. So what I'm going to do, I'm going to bring your slide to stage as well. There we go. Awesome. And I'm going to disappear and pass you the mic.
All right. Thank you very much.
Talk to you later.
Cool. All right. Well, welcome, everyone. Glad you could join us today. So what I'd like to talk about today is basically implementing security in a Kubernetes-based SDLC. A bit about myself. I'm Peter Bennink. I'm 27. Been working as a senior security engineer at Backbase for now 3 months. Basically what I'm doing at Backbase right now is working on their SaaS solution. And I mean, Kubernetes and stuff like that are a part of that. So basically the premise of the whole presentation today is this. A lot of companies get a Kubernetes environment and assume that might solve a lot of problems they have. But it doesn't just do that on its own, of course. That it still requires you to put in the time and set it up in such a way that everyone can actually benefit from it, both from the outside and from the inside of your company. So that's basically what I'd like to discuss today. For a lot of people, it seems that containers in general have some sort of magical security golden hammer aspect to it. Which isn't really true. You still have to set it up in the correct way. Especially in a larger DevOps environment, this can become really chaotic because you have loads of different DevOps teams. They all have different levels of knowledge when it comes to basically their experience with containers or with container orchestration clusters. And while online there are lots of resources about the technical do's and don'ts of such an environment, it's not always completely clear how to integrate this in the right way into your SDLC. So that's basically what I'd like to talk about today. Now, when it comes to the subjects, I try to split it up a bit, make it a bit more organized. So I'd first like to start talking about container images and how to build those and store those and scan those securely. Then I'd like to talk about Kubernetes deployments and clusters. And finally, as a sort of summary as well, I'd like to talk about tools and these resources. So let's start with container images. Now, I split this up into building, scanning, and storing. And one of the keywords I'd like to mention here, or we have two of the keywords I'd like to mention here, are standardization and flexibility. And I'll come back to these multiple times during the presentation, because I think it's basically at the core of doing this correctly. And there's no one solution for every company. So what I'll talk about here, it won't be the solution, the magical thing you can just implement exactly the way I mentioned it, and that will solve everything. That really isn't how it works. It really depends on your exact environment. So let's start talking about building container images. There are basically, in my opinion, two main ways of doing this. The first way would be defining and educating your team and your companies, or your teams and your company, on best practices regarding containers and container security and how to build containers in the best way. The second one would be basically offering build pipeline modules, and that's already where we get into the standardization aspect of this. Is you have a centralized location where you or your Kubernetes or your security team provides these modules, which would basically mean that the individual teams don't really have to do too much work. The only thing they have to do is firstly be aware of the setup that you provide to them, and secondly, implement it in their own pipeline. Apart from that, they don't really have that much control actually. So, but let's start with the first item. So when it comes to best practices, there are multiple aspects to this, and I'm not really going to discuss every single one of them because I think that's something that's already been written out about quite extensively online. But things you could be thinking of is basically which base image to use. So one of the ones that I prefer or that I really like is Distroless by Google. What they do is basically they provide very specific minimalized base images to which you as a user basically only have to provide your application files to. And the rest of the setup is already just there. You don't really have to provide anything else to it, and it only contains that which your application needs. No excess libraries or resources in there. Then obviously something like secrets, making sure that you don't put any secrets into your Docker file and implicitly then also in your Docker container. Something similar to that is basically making sure that your application doesn't run as root in your container. So make sure that you basically have it run as a low privilege user there. And apart from that, and we'll come back to that later on, is building your application in such a way that there aren't any dependencies on resources on the host operating system. So don't rely on the access to specific sysctls or specific kernel capabilities, for instance. Try and reduce that as much as possible because, and we'll come back to this later, from a cluster perspective, it isn't really great to have such a dependency on the host operating systems of the worker nodes. Then the second solution would be basically offering build pipeline modules. So the way that would look like is you have a centralized repository somewhere. That centralized repository holds basically your Docker file. So that's basically a Docker file you write once and audit once. Well, not once, but there's only one Docker file. That's basically what I mean. And then you build around that, you build a pipeline module in some sort of read-only repository somewhere that your individual teams, and this really depends obviously on what pipeline solution you use, but a module that the individual teams can then just use. The only thing they provide as a parameter is basically the location of their application file or files, and it pushes them to the Docker file. The advantage of this is, of course, that you basically only have one type of container image. The only difference between all the application container images of your company would be, the application that's contained in it. And not every company will just have one type of application. Most will have multiple, even thinking like front end and back end. So that's something that you would have to write multiple Docker files for, but at least that way it's still heavily standardized. Most companies will have certain standards regarding languages to be using or regarding the frameworks or other coding standards. So from that perspective, using that standardization and basically extending that to the container image itself is a really good way to standardize everything. One of the disadvantages of the first method is basically that you rely on each individual team to implement this correctly. The only way that you're able to verify this, because manually checking every single image that is generated would cost a lot of time, of course, and a lot of work. So you'll have to start relying more and more on scanning tools. And while scanning tools are great, they also generate a lot of false positives and false negatives. And false positives, that takes time to audit those, and false negatives, I mean, implicitly you don't see them. So that can cause certain issues. And now we get to the scanning part. So regardless of which of these methodologies you pick, scanning will have to be done at multiple times during the SDLC. But let's first talk about what we actually want to start scanning. So in terms of what's happening in there, we have the application libraries, so the dependencies of the application. So let's say Java libraries, for instance. Then we have certain container best practices. So we already talked about that a bit, but basically running your application as a low privilege user, or not putting any secrets in your Docker file, stuff like that. Again, this is something that there is endless resources about this on the internet, and I have a list of them at the end of the presentation. And then we have the operating system level vulnerabilities. And this is very similar to what you might find in a regular, Linux distro. You'll have libraries in there. You'll have permissions, file permissions, and you might have configuration of certain other dependencies of the application. This is the kind of stuff that you might be looking for in such a container image. Now, when it comes to how we want to scan this, there's a lot of scanning tools out there. I just picked a couple, the ones that I like and have some experience with. So Dockle is one. What Dockle does is it does actually also allow you to scan a container image. But what I really like about it is the fact that it also allows you to scan a Docker file. So that means that basically you can already use it while you're just still building, still developing your container image. So that's a really big advantage of it. Something that can easily be ran and checked and used during development. Now, then we have Trivy. And Trivy is a more heavy-duty vulnerability scanner, one that I also really like, but one that makes more sense to run after you've sort of done a certain amount of development, so you can actually start testing an actual container image. And Trivy looks for basically everything that I listed on the left side of the screen. Snyk does something similar, and Snyk obviously has loads of different applications or scanning tools that they provide. But what I really like about Snyk is how it integrates with your IDE. So a developer can actually use it very easily during development. Now, I've also put GitLab, GitHub, and a couple of cloud services on here. Why is that? Because basically all of these also provide some sort of scanning tool integrated with their container registry. And that's something that you can actually take a lot of advantage of. Obviously, within pipeline scanning still needs to be done, because preferably you'd find high severity issues if they are already there in a container image. You preferably find that before you start pushing something to a registry. But obviously, after you start pushing stuff to your registry, you want to keep scanning. And we'll talk about that a bit later as well. But basically, using that integration works really well.
Peter, sorry to
yes.
There is a quick question for you from Peter Bennink. What was the Google-based image you were talking about?
Yeah, so that's distroless. You can find it on GitHub. Can I chat? I don't really see a chatting possibility. No, in any case, it's called distroless. You can find it on GitHub, and they have all the documentation explanations over there.
We'll send the link on Discord. So,
yeah, cool. Thanks. All right. So then let's talk about storing images. Now, there's a couple of things that you have to pay attention to here. In theory, a registry is just that, right? It's just a registry place to put images. But there's still a couple of things that you have to keep in mind. So one of those things is using immutable tags. And I guess, one of the bigger examples of this is the latest tag. I think that's a standard tag in almost every registry. And that's just basically the most recent image pushed to a certain repository. What that means is if you start referring in your Kubernetes deployment to the latest tag, that means that your Kubernetes deployment isn't immutable anymore. Because if you, in the meantime, push a new image to your registry, a new Kubernetes deployment with the exact same deployment file, an unchanged deployment file, will still start deploying a new image. The new image could be anything. I'm not just talking about a new version of an image. That could also mean that it starts using something that someone put in there maliciously. So that's something to take into account. Latest isn't the only type of immutable tag. Obviously, you can start tagging your own images as well. So let's say we have a v2 tag. Doesn't really have to be a problem with using tags like that, because it might be nice just for documentation purposes, but preferably, especially in a production environment, you want to be very, very specific about specifically which container image you're deploying. So from that perspective, it makes sense to have immutable tags that cannot be changed to refer to another image. Now, rescanning, already quickly talked about it a bit. Obviously, initial scanning of a container image is great, but afterwards, stuff can change. New CVEs can come out, new versions of dependencies, not even related to specific vulnerabilities, but obviously you still want to just keep your libraries up to date in general. So rescanning like that will allow you to notice that kind of stuff. Related to that is stale images. So after a certain period of time, you might decide that images will simply either be removed or cannot be deployed to your cluster anymore. So there's settings that you can either set on the registry itself, or you can set that on the cluster, where you can basically say if an image has been pushed or is X days old, it cannot be deployed to the cluster anymore. Then again, related to that, we have the separate production registry. What you can do is have a slightly more relaxed policy regarding the non-production registry, and then have a stricter setup for the container or for the production registry. What that allows you to do is give developers more freedom in a development environment, and then when it comes to production, you can start setting slightly tougher demands. So let's talk about Kubernetes deployments and clusters now. I've split this up in 4 aspects. So we have Helm, we have host and container restrictions, we have policy management, and we have in-cluster isolation. Now, I don't want to give a whole course about what Helm specifically does, but basically, in short, Helm is a package manager and templating engine. When I say package manager, Helm allows you to set up registries or repositories with Helm templates, which are, in that use case, they're basically very similar to just regular Kubernetes deployments, which you can host and other people can really easily apply and spin up in their own clusters. The other aspect is the templating engine. And we have an example of that below here. So what you can see here is we have basically a template. And the template in this case only contains one variable, in this case the image version. Then we have a separate values YAML, which in this case specifies that version as latest at the moment. And what Helm can then do is basically merge those two into an actual Kubernetes deployment that it can then deploy to your cluster. The reason why this is interesting for us is because we can do something similar to what we've done with the container image. What we can do is we can centrally host one Helm template that all of your teams, or again, a portion of your teams, depending on how different all your applications are, can then just grab. They can basically change the values, and the goal here would basically be that they only require changing the values file to tailor make it for their own application, and from there they can just deploy it. So again, very similar to the Dockerfile situation. We host the template in a centralized repository somewhere. Around that, we build a build or release pipeline a module. The teams can grab that, refer to it. Basically, their only input should be their values file, and this values file will then contain the location and name of their image, a couple of other settings. I mean, let's say changing the name, changing some annotations, whatever might be necessary for their application, and from there it can be deployed. That way, you still have full control centrally over the Helm file, while also giving the flexibility back to the teams that they need to deploy their own application with it. Now, when it comes to this situation, again, we have the standardization versus flexibility issue. Obviously, what you could also do is have this template somewhere centrally, but allow teams to pull it and change it themselves. But yeah, then you do lose control, and that does mean that the individual teams or the individual pipelines will have to do more scanning or validation to make sure that there aren't any security issues there. When it comes to security issues and checking those in Kubernetes or Helm deployments, one tool that I really like is Checkov. Checkov has a broad variety of things that it can scan. We can use it for Kubernetes. We can use it for Helm. We can use it for Terraform. Is something we at Backbase currently use it for as well. So yeah, that's basically something that would integrate very nicely, regardless of the exact setup that you have. Then we have the subject of host and container isolation. So what we're trying to achieve here is creating host-agnostic containers. So containers and container images that aren't dependent on the specific host operating system of the different worker nodes, which in itself has multiple advantages because one, you're less reliant on specific changes to the worker node, which will become useful later on in the presentation. In addition to that, what we're also trying to prevent, obviously, is container breakout. That's a very real risk in the container world. So one of the advantages of containers is isolation. However, you can basically, just to give a very short explanation of it, you can basically cancel out all of that isolation by setting things like the list we see here on the right. So for instance, a privileged container, as we can see here in the example, can actually access the host operating system. And from there, it's very possible for someone to actually infiltrate the host operating system, get a shell there. From there, obviously, they can, they have a lot of control over your cluster. So that's something that we're trying to prevent. Now, the list on the right here is just a couple of examples I have of things you have to keep in mind when it comes to a Kubernetes deployment like this. I'm not really going to go through all of this because I think this is the technical part of container security. It can very easily be found online. But I just wanted to give an example of these settings. And that brings me to my next point. How are we going to enforce that? How are we going to enforce that those settings that we just saw aren't set incorrectly by the teams? Now, this is something we have to use policy management for. Now, previously, it was possible for teams to, or for Kubernetes clusters, to use pod security policies. These were really useful, worked really well, but since version 1.25 of Kubernetes, these have been deprecated. So we can't actually use them anymore. So especially if you're spinning up a new cluster now, you really have to find a new solution for this. Now, there's a couple of solutions here. And Kubernetes does have its own admission controller setup as well. But two tools that I've been using that I really enjoy are called Kyverno and Gatekeeper. Personally, I have a slight preference for Kyverno, and that's what I'll mainly be talking about from here. But you can have a look at Gatekeeper as well. It does very similar things. It really depends on exactly what you're looking for. One of the advantages of Kyverno, in my opinion, is the way that it allows us to do scanning based on those policies outside of or pre-deployment to the cluster. So on the right here, we can see a bit how that would work. For Kubernetes, we basically have a policy. Each policy can contain multiple rules. Each rule will then match or exclude based on loads of different variables. So you can basically say we can apply this policy to everything in a namespace, or we can say based on a label. Obviously, resort kinds have to be set. So we're applying this to, let's say, a pod. And what you can do with it, and that's what I really like about it, is we can verify and validate stuff. We can also generate or mutate stuff. So what it allows us to do is to make a decision between either requiring each and every team to set their own security context. But what we can also do is enforce a security context from the platform and basically say to each individual team, don't worry about the security context in your Helm chart. We'll be using this. This is the security context we will apply automatically to your deployment. So that works really well. So yeah, and then we have in-cluster isolation. That's something that can be enforced using Kubernetes as well. And it's a bit different from the host container isolation, of course. What this allows us to do is enforce restrictions on cross-pod or cross-service or cross-namespace communication. So it basically prevents lateral movement. That's basically what happens. We don't want someone to be able to jump from one infiltrated container to another, obviously. So that's already why we're trying to protect our applications as much as possible. In this case, what we'll use it for is to make sure that if there's no reason for one pod to communicate with another pod, or one namespace to communicate with another namespace, to just restrict that. Because if there's no business reason, if there's no actual connection between these applications, then why would we want an attacker to be able to make that connection? It only allows for more freedom for an attacker as such. So what we can do for that is, by default, each namespace within a Kubernetes cluster has or can just communicate with any other namespace, or pods in different namespaces can communicate with each other. What we can set is called a network policy, where we can basically set a deny all between all network or between all namespaces, or between very specific namespaces. And then what we could do is, per namespace, we could either have one application, or we could have one development team, or we could have like groupings of applications that make sense together because they communicate with each other a lot. And then we could allow those different teams or different development teams to set their own network policies to only allow the specific traffic that their application needs between application and application. So that's all for the Kubernetes deployment and cluster aspect of things. But obviously, there's a couple of things that I wanted to mention related to Kubernetes clusters alone. And those are worker nodes and runtime security. So these are things that most development teams won't actually have much to do with, but it does have a couple of implications for them you have to keep in mind. So when it comes to worker nodes, we already talked about host container isolation and making worker node host agnostic container images. And this is basically why, because you want to have full control over what host operating system is running on your worker node. By default, still in quite a lot of situations, worker nodes will simply have like Ubuntu as a host operating system, which is great, but also really unnecessary because you don't really need it for most kubelets. The only thing you really need is kubelet and whatever kubelet depends on, just in real short, of course. So what we can do in this case is look for container worker node host operating systems that are specifically built for the purpose of running a kubelet to basically function as a worker node. So I just picked a couple here, and a couple of these are cloud service dependent. So we have Google Container Optimized Operating System. Obviously, that only works in Google Cloud. We have Bottle Rocket, which is an Amazon developed worker-node operating system. But then we also have Flatcar. I think Flatcar is owned by Microsoft at the moment, but I think they still allow you to run it wherever. And then we also have TalOS. In addition to minimizing attack surface, this also allows you to optimize the resource usage. Because obviously you're not running a massive host operating system, you're just running that which is directly necessary. Then, in addition to that, we have runtime security. Obviously, we try to restrict and secure our applications and our container images as much as possible, but that doesn't always work completely. We can't just rely on just that. So for that purpose, we have runtime security tooling, and one of the major ones at the moment is Falco. So what Falco does is it basically sits behind the Kubernetes audit system, and on each audit event that goes through the audit system, Falco will analyze that event based on its rules, and those rules you can set yourself. Falco has a massive database with like standard rules, so in most cases you won't even have to do that much work on writing your own rules. But it obviously is possible to write them yourself as well. And based on those rules, you can set certain actions, or you can log or notify or whatever. So that's really, that, in my opinion, that's a really great system. At the moment, at least from what I know, Falco seems to be the major offering in that perspective. So yeah, I just wanted to have that mentioned.
Quick question, Peter, from
Yes.
Sergio. Second profiles generate log entries at cluster nodes when violated. How do you address monitoring those log entries?
Well, to be honest, regarding log entries, I'm not completely sure. What I do know is that using something like Kubernetes, and obviously in a security context as well, you can basically just set a specific profile. In most cases, I would not assume that it would be necessary to set a different than default seccomp profile, because that's also related again to the host container isolation, where we basically don't want to depend too much on this kind of functionality. To be honest, I'm not completely sure on these log entries.
We can come back to Sergio later in Discord as well.
Yeah, great. So let's talk about tools a bit. I mentioned quite a lot of them, and what I'd like to make clear, so in the following slides, we'll see a lot of repetition, because a lot of the tools that I picked are on purpose quite multi-applicable. They can basically be used by loads of different people in an SDLC, and they basically fit in a lot of locations as well. The advantage of this is that you have the same rules across your whole pipeline or across your whole SDLC. That allows any developer in your situation, in your company, to locally apply and check for the same policies that you would have at the very end, let's say the production cluster. Which is a massive advantage, because in the end you don't want developers to be surprised by the time that they get to production. By that time, they should be 100% certain that whatever they have runs exactly like they expect it to, and no last minute security issues, basically. So for developers, I already mentioned Docker. What I like about it is the fact that it scans for Docker files. Trivy is a more heavy-duty container scanner, which actually scans container images and scans for way more in-depth. Chekhov is also a really broad tool, but what I specifically like in our situation is using it for Helm or for Kubernetes deployments. Then we have Snyk. Again, just to mention, Snyk has loads of different tools they provide. And their IDE integration is just really well done. Kyverno, again, what I like about Kyverno is the fact that we have the policies. The way that we currently have it set up at Backbase, basically we have a repo somewhere with our policies. Those are applied to the cluster. Then after that, you can pick two ways to use those same policies earlier on in the development process. One would be we can make the policies available, basically the YAMLs of the policies available to the individual development teams. So they can just download them and run them locally on their local deployments, or their local static deployment files, I mean. The other way that they could use them is by interacting with a Kubernetes cluster that has those rules applied. What they can do is do a kubectl apply with the argument dry run equals server. And what this does is basically, well, it's a dry run that communicates with the server. And Kyverno will actually report back specifically which policies that deployment doesn't adhere to. So it will give you back very specific information. In the policies, we can actually define comments and information that we as a specific security team want our development teams to have. So we could even link to like, I don't know, Wikipedia, OWASP, our local Confluence, anything. So that's really useful about it. The fact that you can apply it and basically give back really useful, specific information to your development teams. Then when it comes to pipelines, again, Chekhov, Kyverno, Trivy, Snyk. But at that point, we already get to the image scanning tool. So obviously, technically, the container registry isn't part of the pipelines. I get that. But by that time, after the scanning has gone through in the pipeline, you push it to the registry, and from there it can do its rescanning and stuff like that. And then we get to production, by which in this case I mean both the cluster and the production registry, whether that's a separate registry or the same one. But there we have Kyverno and Gatekeeper as well. Obviously we have Falco, and then we have the aforementioned container scanning tools. Which they just really have to be run not continuously, but at least regularly, because you cannot rely on a single initial scan. Things do change, CVEs come out, stuff like that. You don't want to rely on an initial scan just only then. So when it comes to resources, a couple of things that I didn't mention yet. Two resources that I really like and are really useful are the sys benchmarks and the OWASP cheat sheets. Now, the sys benchmarks are of a really high quality, but they might not be as easily. They're not really intended for like a nice read. It's basically a list of all the controls, and they have very specific explanations of what would pass, what would fail a specific control. The cheat sheets, specifically the Kubernetes and Docker ones from OWASP, they're much nicer for you to just actually have a read through and learn from and educate yourself. And then we have KubeBench and KubeHunter. KubeBench basically tries to check your specific Kubernetes cluster for certain benchmarks from sys. And KubeHunter does a slightly more aggressive scan and actually starts looking for whether your specific cluster might be vulnerable to specific CV. So KubeHunter, really don't run that on your, I wouldn't recommend running either on a actual production environment. Probably better to do that on a staging. But KubeHunter, probably best to not do it on a cluster that other people might rely on, because it could break things in certain cases. So that's it. Thank you very much. If there's any questions, you can either pop them in StreamYard or in Discord, I think. But that's it for me.
Thank you very much, Peter. I don't see any more questions from the channel. Let's have a look at Discord. Not yet. So I have a question for you. I mean, you talk about tools, policies, processes, but what would be for you, let's say, what are the top 3 tasks to take on when you start using Kubernetes to make sure that you do it securely from the beginning?
Well, so I think the most important thing is figuring out what specifically your users of your cluster need. Because in the end, the security of your cluster and, well, the specific ways in which you need to secure your cluster really depend on your specific application. So figuring that out, figuring out what your applications currently depend on in terms of an on-cluster environment, that's really important. Secondly, after you figure that out, obviously you can start creating stuff like basically the Helm charts and the Docker files that I mentioned. But at that point, a secondary step will obviously be to see whether you can, together with the development teams, improve those applications so they might maybe rely less on the cluster and less on the back end of the cluster. I think those are probably the most important things. And what I'd like to mention as well is the fact that I gave the explanation of flexibility versus standardization. And flexibility implied a lot of educating. In general, I would still be for educating even if you're standardizing. Because in the end, even in a standardized environment, you still want people to know why stuff is done the way it's done. So that education part is really important. It's just that the immediate necessity for it becomes a bit less when you're standardizing stuff, because there's less direct reliance on that for the production security.
Yeah, I'm totally with you on this. Training developers against vulnerabilities and risks should be always there. So are you also doing pen tests on containers, Kubernetes, or cluster pen testing in Backbase? Or
so at the moment, I'm not doing that much pen testing at the moment. We're working on building a new environment. So there's a lot of more security architecture at the moment. I think in a couple of months we'll start doing some more pen testing. At the moment, it's basically just more getting everything set up correctly.
I was curious if you found some cool vulnerabilities. That's why.
No, I'm sorry.
No, yeah.
Next time, maybe. Next time.
Okay. For the next talk.
Yeah, exactly.
All right. Well, if we don't have any more questions, I guess that's all we have today. I want to thank Peter. Thanks, Peter, for joining us today. It was a great talk. So I hope to see you again for another talk. If you have a cool vulnerability again, just come back. Let me know. And
sounds fun.
Our next session for DevSecOn, it will happen end of May. So stay tuned. We'll publish the talk soon. And well, I will see you in a month. We've been DevSecOn, and again, this is an inclusive community that educates and enables developers in application security and DevSecOps. Thank you, everybody, and see you in 1 month. Do it.